This video is going to be over how to solve some of the problems out of Chapter 5, Section 4. This is sort of a building section in that most of the techniques that are learned in this section aren't used in and of themselves. Rather, they're used to help us do something else. So I would call this a technique building section. Let's start with the first problem. It says use long division to divide. Specify the quotient and the remainder. In order to do that, let's first take an example of a problem that you learned to do in 4th grade using long division. I have written down two versions of exactly the same mathematical expression. In one form, it looks like a fraction, 43,612 divided by 213. And the second version of it, you can see the long division notation with the curved sidebar and the long flat horizontal top. The number that's from the numerator goes underneath the long division bar, and the number that's underneath, called the divisor, goes outside the curved section. The quotient will be on top. So the number that goes on top is going to be the quotient. If we have anything left over or a remainder, it will go out to the side. This number that goes outside the curved section is called the divisor, and the number that's underneath, this is actually called the dividend. You won't be tested on what the names are, but they will be referring to the quotient, the remainder, and the divisor fairly regularly, so it would help to know what they are. Let's remind ourselves how we do long division. In order to start, we won't take exactly 213. Instead, we'll estimate. So our first step in long division is to come up with an estimate. Since 213 is just over 200, I'm going to estimate with 200. 200 will not go into 4 or into 43. It will go into 436. So I'm going to estimate that 213 goes into 436 2 times. I'm going to put my estimate up here in the quotient position above the 6. My next step is to multiply my estimate by my true divisor. So step 2 is to multiply. When I multiply, I'm going to take my estimate and multiply by what I actually have. 2 times 3 gives me a 6, 2 times 1 is 2, and 2 times 2 gives me 4. That is multiplication. Check to make sure that your product is smaller than what's in the dividend. If it is bigger, then your estimate was too high and you need to erase and start over with a smaller estimate. My next step is to subtract. Subtracting with polynomials means that we will change the signs and add, since subtraction changes all signs. For numbers, we can simply put the minus out front and draw the horizontal bar to subtract. 6 minus 6 gives me 0, 3 minus 2 gives me 1, and 4 minus 4 is 0 again. I check to make sure that what is left after I've subtracted is smaller than my divisor. If my divisor were 213 or bigger, that would mean that my original estimate was too small, and I should increase the estimate. I would need to subtract all the work I had done, increase the estimate, and remultiply. Since my remainder here is 10, that is smaller than 213, so my estimate was correct. The next step in long division is to bring down. When we're doing it with numbers, we typically bring down one number at a time. With polynomials, we often bring down everything each time, for the simple reason that we have a bad habit of not working in perfect columns, and sometimes our work kind of goes crooked across the page, and it's easier not to lose things if we bring it all down at once. By bring down, with numbers, I would bring down the next one. In this case, then we would start over again, and I would do my estimate. My estimate is there's no way to put 213 into 101. I'm estimating 0. If I multiplied, I would get 0, and when I subtract 0, I would still have 101. But then I would bring down again, so I would bring down the 2. Now 200 will go into 1012, but because this is a little more than 200 and this is barely over 1000, I think 5 will be too much. So I'm going to estimate 4. I put the 4 above the 2 I just brought down. There's my brought down 2. And now I multiply again. 4 times 3 gives me 12, carry my 1. 4 times 1 is 4, plus 1 is 5. 4 times 2 is 8. My estimate here, my 852 product, is smaller than what I had brought down before from the remainder, so I know that my estimate of 4 is not too big. The question is it too small? To find that out, I need to subtract the number and see if my remainder is bigger than 213. 2 minus 2 gives me 0. I cannot subtract 5 from 1, so I borrow from the 10, make it a 9, make that an 11. 11 minus 5 is now 6, and 9 minus 8 is 1. My remainder is 160, which is smaller than 213, so my estimate was not too small. This means that if I'm writing 43,612 divided by 213, the quotient is 204, but there was a 160 that never did divide by the 213. In other words, I put the remainder over the divisor as what's left over. The quotient is 204, the remainder is 160. Let's look at how to apply these same steps to polynomials now. Scrolling down, we're going to return to the original first problem. X squared plus 2x minus 20 divided by x plus 5. In this notation, we've used the bar dot dot for division, but we could have written it with a fraction form instead. They want us to use long division, so even if it factors, we will not get credit for doing it that way. To do long division, I'm going to use the long division notation, the curved left section and the long flat horizontal bar. What's in the numerator goes underneath the long division symbol. Notice that I will make sure that I have something for each of the powers of x from the highest degree down. Since my highest degree is 2, that means I want to have a place for x to the first and constants as well. I'll take my divisor and put it on the outside. Now I start with the same steps I used before in the numbers only problem. First, I estimate. For my estimate with polynomials, I'm not really guessing. An estimate with polynomials is precise. Take the highest degree term in the dividend, x squared, and divide it by the highest degree term in the divisor, x to the first. That gives me exactly x. That is your estimate. In other words, what would you need to multiply x by to get x squared? I would need another x. The second step is to multiply. Now we take our estimate and we multiply by the actual divisor. X times x should give me exactly the same first term in the dividend. X times positive 5 gives me a plus 5x, which I will line up under the other x to the first term. The third step in long division is to subtract. When you subtract with polynomials, the easy way is to change all the signs. I put parentheses around the product and a minus on the outside. I also go one step further and actually write the changed signs with a circle around them so I know which ones to use. The minus will change this to minus x squared minus 5x. Now, in order to subtract, I just combine the two polynomials with the opposite signs applied to the product. X squared minus x squared is 0. If the first terms don't cancel, your estimate was incorrect. You need to erase and start over by re-estimating. 2x minus 5x gives me a minus 3x. Now I will bring down. With numbers, you can bring them down one at a time, and you can do the same with polynomials, but it's good practice to bring the whole thing down each time so you don't lose a term. Now we start over. What would I multiply x by to get minus 3x? I would need to multiply by a negative 3. Again, the estimate step with polynomials is not really a guess. You can compute it. Take the highest, which is minus 3x, and divide by the highest degree term in the divisor, which is x. That gives you your estimate of negative 3. Next step is to multiply again. So I take negative 3 times x, which gives me negative 3x. The first term should be identical. Then I distribute negative 3 times 5 and get minus 15. The third step is to subtract. For polynomials, that means put a minus outside parentheses around the entire product. I like to change the signs and actually physically write what the new sign will be with a circle around it so I know which one to use. When I add these together, negative 3x plus 3x cancels. Negative 20 plus 15 gives me a negative 5. My quotient is x minus 3, and the negative 5 is the remainder. That my solution is x minus 3 minus a 5 that never got divided by the x plus 5. Let's take a look at the next one. On the next problem, I have what I call a hole in the dividend. If you look at the dividend here, you'll see that it has an x squared term and it has a constant term, but it is missing the x term. We're going to fill in this missing spot with a 0x to hold its place. Just like in the number 1001, we have 2 zeros to hold the hundreds place and the tens place. Now we write the symbol for long division. We put the x minus 1 divisor on the outside. On the inside, I'm going to put 3x squared minus 8, but I'm going to add a 0x term to hold the place for any x terms that come up in future products. Then I'm going to have the minus 8 out at the end. Now I run through my steps. Step 1, estimate. What do I need to multiply x by to get 3x squared? A positive 3x. Or again, take the highest degree term in the dividend, 3x squared, divide by the highest degree term in the divisor of x, and that gives you your first estimate, 3x. Now we multiply. When I multiply, I get 3x times x is 3x squared. First terms always match precisely. 3x times negative 1 is a minus 3x. This is why I filled in the hole with the missing 0x. Otherwise, I would have the minus 3x written under the minus 8, and I would be tempted to add two terms that are not alike. The third step in long division is to subtract. To subtract, I'm going to subtract with minus on the outside and parentheses around the product. I like to go in and physically write what the new sign is with a circle around it so I know which one to use. When I combine these two lines together, the first term should always zero out. 0x plus 3x should give me 3x. The last step in the long division process is to bring down. I'll be bringing down all of the polynomial that's left each time. In this case, just the minus 8. Then we start over again with our estimate. Highest degree term out of the dividend is 3x, divided by highest degree term out of the divisor is x. That gives me a positive 3. That positive 3 belongs in the quotient with the plus in between the two terms. Now I multiply. That's the second step in the process. 3 times x gives me a positive 3x. 3 times negative 1 gives me a negative 3. Third step, subtract. Put a minus with parentheses around the whole product. Change the signs and circle them so you know which ones to use. Combine the two lines from long division. The first should always cancel out completely. The second, negative 8 plus 3, gives me a negative 5. The negative 5 is the remainder. The quotient is 3x plus 3. The solution would be 3x plus 3 minus 5 over x minus 1. I never did divide that negative 5 by x minus 1. Let's take a look at one more problem, which is a little bit longer and a little bit more difficult. In this case, I have a missing x squared term, and my divisor has a coefficient on the x term. Let's see what difference this makes. I'm going to write the long division symbol. I'm going to put the dividend underneath it. The highest degree term is x cubed, so I need a spot for x squareds, a spot for x's, and a spot for constants. I have no x squared terms in the dividend, so I can fill it in with 0x squared. Then minus 16x, then plus 2. On the outside of the symbol, to the left of the curved section, I put the divisor 2x plus 4. Now I do the steps of long division. Step 1, estimate. Again, to estimate, take the highest degree term in the divisor, 4x cubed, and divide by the highest degree term in the divisor, 2x. That would give me a 2x squared. This time my estimate is not just a constant or an x, it's 2x squared. My next step is to multiply. I'm going to take my estimate, 2x squared, and multiply it by each term in the original divisor. That would give me the 4x cubed I had for the first term. 2x squared times 4 would give me a plus 8x squared, which I line up under the 0x squared. Now I need to subtract. To subtract, we'll put the product in parentheses with a minus out front. We'll change the signs and circle them so we know which ones to use. When I combine the first terms, they always completely cancel. 0x squared minus 8x squared is a negative 8x squared. My last step in the long division process is to bring down the next term. I'll bring the whole thing down since I have a bad habit of not lining mine up very well, and that prevents me from forgetting about a term. Now I start over. Estimate. Now my highest degree term in the dividend part is negative 8x squared, and I divide by, again, the highest degree in the divisor, 2x. That gives me a negative 4x. The negative is a part of the quotient and becomes the sign between the terms. Now I multiply so that I will get exactly negative 8x squared for the first term again, and minus 16x for the second term. You can see what's coming on the third step when I subtract. Those are going to cancel out and go away completely. When I combine them, it gives me 0. I still need to bring down the plus 2. Now, my next would be to estimate again, but I can't multiply 2x by anything to get 2 without involving fractions. The degree of the divisor is degree 1, and 2 is degree 0. When the degree of the remainder is smaller than the degree of the divisor, we stop. That means my remainder is 2. Let's try one more. This one wants us to use synthetic division. Now, synthetic division is a different process from long division. It is, in fact, a shorter way of doing long division without having to write the variable parts of each term. Let's go back to the ones above and we'll rework them, but we'll be using synthetic division instead. The original first problem has been reproduced for you here. Previously, we used long division to solve this problem. Here's what it looked like in long division. We got a solution of a quotient of x minus 3 plus the remainder negative 5, which was never divided by x plus 5. Let's take a look at the synthetic division process to see what happens. Now, the synthetic division process is going to use the coefficients attached to the dividend and the solution associated with the factor of the divisor. Let's look at it in pieces. If the divisor is x plus 5, then what would the solution to it be? Divisor is factor x plus 5, then the solution, or x-intercept, would be x plus 5 equal to 0, or x equals negative 5. Synthetic division will use the solution associated with each factor rather than the factor x plus 5. Again, look above. When we did the long division, we used the factor x plus 5, but when we do synthetic division, we're going to use the solution associated with that factor, or minus 5. Our symbol is also different in that it's a little bit upside down and the left side is not curved. In here, we're going to put the coefficients of the dividend in order. On the long division process, it is possible to do it without filling in the missing terms, but not on synthetic. If you miss a missing term on synthetic, your answer will be wrong. That means if your degree is 2, like in this one, because we have x squared, you should have 3 constants written down. 1 is the coefficient of x squared, 2 is the coefficient of the x term, and minus 20 is the constant. They must be written in descending power of the variable. It must be the x squared coefficient first, then the x coefficient, then the constant. The process is a little tricky at first, but I think you'll get the hang of it after doing 2 or 3. The first number just drops through, and you write it directly. You're going to multiply diagonally to the left and write the number diagonally to the right, and then you'll add down. So the first number drops through because 1 plus nothing is 1. Then 1 times -5 would give me -5. Now add these together. 2 minus 5 will give me a -3. Multiply diagonally to the left. -5 times -3 is a positive 15. Now add down, get -5. Put a box around the last number. The last number is the remainder. The part that you got here at the bottom without the remainder, this is the quotient. What does it mean? If the original dividend is x squared and I do division by x to the first, the quotient must be x to the first as well. So the quotient must be 1x minus 3 plus the -5 that never got divided by x plus 5. If you will look above, you'll see that that is the same result we got when we did it with long division. Let's do another one of the ones that we worked before. We worked for the second example, 3x squared minus 8 divided by x minus 1. This one had a hole for the x term. You must fill in the hole to do synthetic division. Let's take a look at what this would look like. Here is the problem for example 2 reproduced for you. We've got 3x squared minus 8 divided by x minus 1. If I put this into my synthetic division process, then what I need to have is the solution that belongs to the factor x minus 1. So my divisor is x minus 1, which has solution of x equal 1. Again, this is coming because I set the factor equal to 0 and I solve for x. So I'm going to have a positive 1 on the outside of my symbol. On the inside, I need the coefficients of the x squared term, the x term, and the constant. The coefficient of the x squared term is 3, but I do not have an x term, so I must fill that in with a 0. The constant is -8. Draw your second horizontal line and follow the process. Adding in a column, the 3 drops through. Multiply diagonally to the left, I get 3. Add down, I get 3. 3 times 1, I get 3. Add down, I get -5. What does this mean? If I'm looking at the solution, the last number is the remainder. I take the remainder and I set it aside. The first part is 1 degree less than the original dividend, which means this must be 3x plus 3 because there's no negative, plus the -5 that never got divided by x minus 1. Is that what we got previously? Yes, it is. 3x plus 3 plus the -5 that never got divided by x minus 1. Now let's return to the one that we were looking at a moment ago. Can we work this one? Is x minus 2 a factor of this? To be a factor means that the remainder is 0. If I'm looking at that, then what solution belongs to the factor x minus 2? The solution would be x equal 2. I take the 2 and I put it outside the symbol. If my highest degree is x cubed, I should have 4 numbers. 1 for the x cubed, the coefficient is 2. 1 for x squared, the coefficient's -6. 1 for the x term, coefficient's 3. And 1 for the constant, which is the final one. Draw your second horizontal bar. Add straight down to get 2. Multiply the 2 diagonally to the left times 2 to get 4. Add the column straight down to get -2. -2 times 2 would give me -4. Add the column down to get -1. -1 times 2 gives me -2. Add the column down to get 4. The last number is the remainder. Since the original is 2x cubed, then the quotient has to be 1 degree less, or x squared. It must be 2x squared minus 2x minus 1 plus 4 that never got divided by x minus 2. Now, what does this mean in relationship to the graph? On the graph, the 2 and the 4 that you get for the remainder actually means that when x is 2, the y value is 4, which means that that is a point on the graph. This is called the remainder theorem. Let's take a look at one more. When I'm looking at this problem, let's find the quotient and the remainder and decide whether or not 3 is an actual x-intercept. The divisor is coming from the denominator of the fraction, and the solution that belongs to the factor x minus 3 is x equal 3. I'm going to put the 3 outside the symbol. Now I need to put the coefficients of the dividend, or the numerator, into the notation 1 for each power of x. Since it's x cubed, I should have 4 numbers, 1 for each power of x plus the constant. The coefficient of the x cubed term is 4. I don't have an x squared term, so I fill in with a 0. I don't have an x term, so I fill that in with a 0. I do have a constant, so I write it down. If you do not include the wholes, or the zeros, you will get the wrong answer. Now follow the process. 4 plus nothing is still 4. Multiply diagonally to the left, but write it diagonally to the right. That gives me 12. Add down, I get 12. 12 times 3 is 36, diagonally up to the right. Adding down, I get 36. 36 times 3 would be 108, which I write diagonally to the right. Adding down, I get -2. That last number is the remainder. Since it was degree 3, this means that 4x cubed minus 110 divided by x minus 3 is equal to 4x squared plus 12x plus 36 plus a -2, which was not divided by x minus 3. If you were to work that out, you would get exactly the same values. This is the end of this video.